This picture illustrates a model that meets the assumption of homoscedasticity. In this model, savings on the y-axis here is the dependent variable, and income is the independent variable. These lines represent different values of income. And these normal curves here represent the distribution of the errors for observations at those different income levels. So the regression model made predictions for observations at these different levels of income here, here, and here. And the errors are just the difference between the actual values of savings and the estimated savings from the model. The mean of all of these errors should collectively be 0. And the errors are distributed in a similar pattern across all values of income. They are all distributed like a normal curve. Most often, our regression models violate homoscedasticity. When we violate homoscedasticity, we call it heteroscedasticity. This just means the variance of the error term is not the same across all values of our independent variable. Substantively, this means that our model estimates our dependent variable better at some values of our independent variable and worse at other values of our independent variable. This picture illustrates a model that is heteroscedastic. In this model, savings is the dependent variable and income is the independent variable. These lines here represent different values of income. And these curves represent the distribution of the errors for observations at these different levels of income. So the regression model made predictions for observations at these different levels of income here, here, and here. And the errors are just the difference between the actual values of savings and the estimated savings from the model. Now, the mean of all of these errors should collectively be 0. But the errors are distributed in a different pattern across these values. The regression model is really good at predicting savings when income is low, as illustrated by this thin distribution here. The mean of the errors is low, and most of the errors are close to that mean. On the other hand, the regression model does a poor job at predicting savings when income is high, as illustrated by this flat distribution here. The mean of the errors is higher, and there are a lot of errors that are even higher than this mean, illustrated by the more flat distribution.